Yeah, hi everyone. Today we are going to start learning data structures and algorithms. The first one is, so what is a data structure and why we are implementing those data structures and algorithms? See, for every application, so what is the main purpose of application? Using programming, using programming, we are developing the applications. We are developing applications, okay. So what is the purpose of application? Suppose if you take that banking application, one simple example so that everyone will understand. What is the purpose of bank application? So what bank application will do? It's very simple. It will store customers' information. It will store, it will store customers' information. And after storing the customers' information, it will it will perform operations on customers information. It will do operations on customers information. These are two things it will do. All in customers information it will store. Customers means what? It's a record type information. It's a record type information. Here we can store information in different types of format. So that is actually called structuring the information. Depends on our requirement. Depends on our requirement. We can store the information in different formats. So that is actually called structuring the information. After that, we are giving the functionality to access the information. Suppose, sir, I want to store the information like how many records I know. Suppose if you take like array, just generally simple example, I'll explain. Simple example. Here it is. I want to store fixed number of elements like a 10, 20, 30, 40, 50, suppose. The fixed number of elements. And if you want to access the data in the most easiest way with the help of their index, quickly we are accessing. Quickly we are accessing this information. Suppose I want to access this one, which is in the third location. We are getting that information. This is one way. So sometimes we are displaying that information in the first come, first serve. Suppose is a queue data structure, simply to say. Simply to say. The one you enter from the rear. So here it is, who will come first? Is a come first. That person only will serve first and it will come out of that one. It's a queue data structure. Is a queue data structure. No, sir. I just want to display the info. I want to store the information in what way? What you have inserted last should come out first. Should come out first. What you have inserted last, that should come first. Then you can go with that stack data structure. From top, suppose if you insert like this, the 10 you are inserting, the 20 we are inserting, this 30 we are inserting, this 40 we are inserting, and it will come out. That last one, what you have inserted, it will come out first. This is the way. Sir, after insertion, I want to inject the information in the middle whenever I want. Whenever I want, then we can go with the linked list. Suppose if I want to insert somewhere in the middle, we break this one and we connect this one. We connect this one. See, for every application, what we do, we store the information, okay. But in what way? In what way we store the information means what? That is depends on our requirement. That is depends on completely application requirement. We store the information completely based on application requirement. That is okay. Now, so different data structures are there. We can call it as a linear data structures. Is a data structures. Data structures. Simply, we can say that as a linear data structures and non-linear data structures. Is a linear and non-linear data structures. So what are linear data structures? What are linear data structures? Arrays is a stack, is a queue, and we can say that is a linked list. Linear means one element is connected to only one element like this in a linear format. In a linear format like this. Left side or right side. In a linear form only it will come. Non-linear data structures means what? Is it trees and graphs? Nothing but, suppose if you take the tree, the one is connected to multiple nodes. One element is connected to number of nodes. This is what we called a tree. Graph means what is completely different. One node is connected to any number of nodes. There is no limitation at all. There is no limitation at all. It can connect like anything. It can connect like anything. It's what? It's what a graph like this. And that is called non-linear data structure. Sir, why we need to structure the data? First of all, what is the purpose of data? For every application is for simply two reasons only. Application is for simply two reasons. One is for storing the information. Second one is what? Is a processing information. We store the information in different ways. Depends on our requirement. But while storing the information, you have to structure the data properly. Properly, you have to arrange the data. What is the purpose? If you arrange the data in a proper format, easily you can access the data after completion. Depends on the requirement. Easily we can access the information. That is okay. And so what are the main concepts we are using to learn this one? Mainly the basic concepts we are using, just like a object creation, classes and objects, methods, and arrays. This knowledge is required. This knowledge is required. And for linked list, we use one concept in Java is called as a relation. I'll explain all these things. So whenever we are using every single concept, I'm going to explain. Then only we will enter into that one. Okay. Now, first, We need to start with the data structure called stack data structure. Is a stack. First one is whenever you are creating this stack, we use array. We use array. So normally, how you represent the array in Java? Integer array. But only the name will change. It's like a stack. And we use the size. New integer of, we specify the size here. So whatever the size, you can fix here. Int size is equal to any size. If you give 5. If you give 5. Theoretically, I'll explain. And here it is. At the same time, we will write the logic is the first time. Second time, same logic we will see at the time of implementation, code implementation, so that you will understand. So with the sizes of 5, stack will be created. Normally, sir, array we are representing like this now, but now stack we are representing in this format, just like array only, but you are representing in different way. That's it. That's it. Suppose I'm representing like this. 3, 4 is a 5. 3, 4, 5. I'm just giving that index 0, 1, 2, 3, and 4. 0, 1, 2, 3, 4. This is. Suppose this is called a stack. Is called a stack. Because the name I am giving here, it is a stack. Name I am giving stack. And we already discussed that into the stack, we are performing all operations from the top. Either you insert or you retrieve. Nothing but or you delete. Both the operations, either you insert or delete from the option is a top. It is called top of the stack. Inserting element means what? Push. Technically. Deleting the element is called pop. Push and pop the items. Pushing the element and pop the elements from the stack. Okay. Now, if I want to push the element, but sir, what is the top value? Look at this. Initially, top is representing -1. Why top is representing -1? Because it is not pointing to any location. It is not pointing as of now. It's not pointing to any location. Sir, how to write the code? It's very easily you can write the code. See, observe. Sir, I want to push element onto the stack. We define one function, or simply we can say that method. Push 10 means what? Simple logic only. Simple logic. Increase the top value. After increasing the top value, into stack of top, you are storing that element 10. Observe this. Top plus plus means what? Top value 1 becomes 0. See, you are pushing from the top only, but it will go down, go down, go down, go down, and that element will stay here. The element will stay here. The 10 will be pushed here. See, into stack of top. What is the top value? 0. So into 0th location only that element will store. That is, sir, again we push the item. Push 20. Push 20. Again same top plus plus. Top plus plus into stack of top is a 20 we are insert. Here it is a 20 we insert. Because the stack plus, I mean top plus plus means what? First it will become 1. It will become 1. Again same story. Push 30. Push 30 is the same one, is a top plus plus, is a stack of top into that top location 30. The same logic we will write in the code. So that's why I'm showing. Here it is into that location second, that value 30 inserted. This is what pushing the items onto the stack. Pushing the items onto the stack. Sir, suppose if you want to check the peak element. Peak means what? It has to show top element of the stack. Top element means what? Simply you write that stack of top. Top value is a 2. Stack of top means what? That element which is present. That element which is present. So it will show that the top of the stack value is a 30. This is what? Peak item. This is what? Peak item is a 1. Hope you got it. Sir, how many elements are there? All the elements I want to display. How many elements are present in the stack? All the elements I want to display. Okay. So you are just repeating the loop from either top to 0 or 0 to top. So anything. Using the simple loop, because look at this 2. 2 is a top location. Sir, I want to display in this order 30, 20, 10, top to 0 or 0 to top. Top to 0 I am using. Top to 0 for, okay, I equals to top, I greater than or equal to 0, I minus minus. It's a decreasing order. Just every time we are printing that stack of I, not top, I. Because what is that? I value is a starting from 2. So first, second location element, it will decrease. First location element, it will decrease. 0th location element is a 0th location element. This is what printing. This is what printing. Sir, so you keep on inserting the data. You keep on inserting the data. These two, okay. So again, we are inserting push 40, we insert. Next one, push 50, we insert. Push 50, we insert. Then what will happen? Top value become 3. Into the third location, 40 will go. And next one is a top value become 4. Into that 50 will store. Now look at that. The stack is full actually. Stack is full. So normally, whenever you are inserting the element onto the stack, every time you have to check that stack is full or not. Stack is full or not. When top value reaches 4, it's a full. Size value 5. Na? Based on this, we need to write the condition. Nothing but if top value whenever reaches size minus 1. Why, sir? Size minus 1? Because index is starting with a 0. Simply, we say that stack is full. Simply, we say that what? Stack is full. Hope you got it. Okay. Stack is a full. Now, whenever you are going to delete, observe this. This part is very, very important. Whenever you are pushing, what is the element you want to push that you can decide. But whenever you pop, you cannot decide the element because always it will give stack of top element is deleted item and the top value will decrease. Pushing means what? Increase the top and insert. Deleting means what? Display that element as deleted top minus minus. This is a very, very important point. Sir, suppose a stack of top means what? Yes, top value is a 4. Stack of top means what? We are saying that 50 is going to delete. Top minus minus means what? From the 4, again is a top coming back to 3. Now top is pointing to this one. Is it meaning, sir? Is it 50 deleted? We can say that yes, 50 is deleted, but actually 50 will not delete. It is impossible to delete the data which is present in the memory. We just make the pointer is not pointing to that location. See, now top is pointing to third location. So this is inaccessible data. No one can access this data. No one can access this data. See, just consider you are the programmer. You are developing the banking application. Consider. Normally, how you will develop the banking application if one customer entered into that ATM center and they push card into that ATM machine and they try to check their account details. Yes, they can check their account details. No problem in that. But they cannot check other account details. But still other account details are there. As a programmer, you have restricted. You have restricted that other people, other people cannot check. In the same way, data is there. Then what is the use of this data, sir? You can't delete. But, sir, suppose if I push again, then look at this. Sir, if I push 60, consider 60, then what will happen? Top plus plus. Then that item will push. By that time, 50 is replaced with 60. You can replace the data, but you cannot delete the data because most of the students will ask the question, sir, by just writing the top minus minus, will data deleted? No, data not deleted. But still you cannot access the data. Sir, if you try to access the data, as a programmer, you can access the data, but you should not give the chance. That's not the stack. Sir, no, sir, I will write the code to access the data. Means you are not implementing the stack. Implementing the stack means you should follow the stack rules. That is. When you push it again, sir, then what will happen? That 50 is replaced with the new value. Like this. Sir, I'm deleting that next one also. The top value will decrease to 2. Sir, I'm deleting that next value also. The top value will become to 1. I'm deleting that next value also. The top value is become 0. Sir, I'm deleting that next value also. The top value become -1. It's an empty, na? It's an empty. When stack is empty, top value is a -1. See in the beginning also, top value -1. So simple condition, if the top value is equals to -1, we can say that it's a stack is empty. We can say that stack is empty. These are the questions, and this is the simple implementation you need to do in the stack implementation. Simple example. Let me write the code so that everyone will understand. Everyone. Any compiler you can use, just online compiler I'm using, anything. Initially, that simple code I'll write. With the different ways we can implement, I'll show you all. Okay now. Now, first I'm taking that size. What is the size of the stack? What is the size of the stack? I'm just giving. Sir, any size I'm giving. No, sir. I want to read from the user. Import java.util.scanner. Create the object of the scanner equal to new scanner of system.in. We ask enter the size of the stack. We just read simply sa.nextInt of. sa.nextInt of. After that size of the stack, we have to create that stack na? Integer stack equal to new integer with that size. That empty stack will be created. Not only that, top equal to -1. Top equal to -1. This is the one. Once the stack is ready, just giving the small message is a stack is ready. A simple example. First simple code I am writing. Suppose if I am giving that size is of 5, stack is ready. Is taking that size, creating that stack with the specified size. We're just making that stack is ready. Now I'm giving that options. I'm giving that options. What are the stack operations? One is to push onto the stack. Push. Two is to pop. Three is to checking the top element of the stack. It's called peak. It's called peak. The fourth option is traverse or display, we can say. And the next one, just we stop, exit. The operations we are providing. Which operation you want to do on the stack. Okay, I'm just giving what is your choice. Enter your choice. Enter your choice. We are taking that choice. We are taking that choice. sa.nextInt of. Based on the choice, sir, if choice is equals to 1, push operation logic. If choice is equals to 2, pop operation logic. Else if choice equals to 3, peak operation logic. If choice is equals to 4, I'll explain. And is for exit, and in case if they enter invalid choice. The queries, yeah, you can ask any query. The now. So based on that, see, suppose if the choice is 1, that is for push the element onto the stack. So what is the element you want to push? So first we ask enter element to push. Just giving that message. Enter element to push. That I'm reading. Element equals to scan dot next in top. This is the element we are going to push. Okay. Now here, how to execute? Already we have written that. Just increase the top value, top plus plus. After that, into that stack of top, you please place that element and simple message pushed onto the stack. Pushed onto the stack. Sir, without checking stack is full or not, how can we push? Yes. This information you need to place in the if block. So what is the top? Already we have seen when top reaches that size minus 1, we can say that it's a full. If stack is not full, then only we can push. Whenever the top value reaches that size minus 1, this condition already we have seen, we can say that stack is full. Stack is full. Or simply they can call stack is overflow like that. Stack is full or stack is overflow like that they will tell. Next one is a pop. Pop means what? First we have to check that stack is empty or not. As soon as stack is created, it is empty. By that time, top value is a minus 1. When top value is a minus 1, we can say that stack is empty. Stack is empty. If not, directly we are giving that element is a pop. Which item popped? Stack of top item pop. And I already told you that after showing that item is pop, just give top minus minus. At the time of insertion, top plus plus and then insert. At the time of deletion, display and do top minus minus. The third one is peak. Peak means what? It will show the top element only. See, just like this, it will show the top element only, but it will not delete. Except top minus minus, the same code. If top equal to minus 1, is a stack is empty. Stack is empty. If stack is not empty, peak item is that stack of top printing, but don't use top minus minus. Is nothing but don't delete the item. Don't delete the item. That next one is a CH choice is a 4. It's for traverse. Sir, for displaying also, Displaying also, we have to check empty or not. Because sir, if stack is empty, you can't display the data. If stack is not empty, stack elements are or stack items. Stack items, I already told you in the logic, either from top to 0 or 0 to top. Here top to 0 I'm writing. Top to 0 I'm writing. System.out.println. It's a stack of I. Is a stack of I like this. Is a 5 means what? Is a simply exit. Just giving that one simple message, end of stack operations. And simply I'm using that break. And if it is other than 1, 2, 3, 4, 5, just giving that simple message is error, is invalid choice. Is invalid choice. All these are. When you run the code, size of the stack I'm giving 5. Stack is ready. Enter your choice. Look at this. 1 is for push. 10 I'm pushing. Pushed onto the stack. Next one, choice is again 1. 20 I want to push. 20. Choice is again 1. 30 I want to push. Choice is again 1. 40 I want to push. Choice is again 1. 50 I want to push. If I display the data for stack items 50, 40, 30, 20, 10 printing. If I see that peak item 3, 50. Again peak item is a again peak item 50 only. Because peak item means always it will show the top element, but it will not delete. But if you go with the pop, sir, already 5 elements are there. I want to push it again. I want to push it again. 60. Now you will get error is a stack is full. You can't push. You can pop. 2. Popped item is a 50. After pop, if you traverse, items 40, 30, 20, 10 only there. Go with the peak is a 40. Sir, I keep on deleting. 40 popped, 40 popped, 30. Next one is a 20. Next one is a 10. Again, I want to pop. It's not there. So stack is empty. If I give that 5, it will exit. This is the simple way of doing stack operations using that array.